In this lesson, we're going to look at probability. Our objectives are to understand what probability is and to understand how to find probability. Vocabulary for this is outcome, possible result. Probability, chance something will happen. There are really two types of probability: an experimental probability where we actually do the work, and a theoretical probability where we're trying to predict something based off of a total. Event, set of desired outcomes, and trial, each collection of data. So each time we do something that gives us more data, that's considered a trial. So to understand probability, what we first need to start with is some type of data. So in this case, what I've done is I've taken data based off of a collection in a forest of different types of squirrels. There are four registered types of squirrels that data was collected on: black males, gray males, black females, and gray females. And then here is the frequency each type of squirrel was found. So 820 black males, 380 gray males, 100 black females, and 170 gray females. Well, what we want to do is to look at probability. We actually start with fractions. Typically, probability is written as either a fraction or a decimal, and sometimes also as a percent. So what I have here is we take the probability based off of the total. This is very similar to relative frequency, or the relative frequency graphs from the previous video. So 820 over 1470. We then divide that out, and we'll typically round our decimal to the second place value or the hundredths place value. So 820 over 1470, we can leave it as a fraction, we can reduce the fraction, or we can turn it into a decimal like 0.56. And then the last step is sometimes we will want them as percents, so that would be 56%. If you want to, you can take your calculator out and check my math on that. Now, as we round these, we always want the probabilities to add up to the total, which would always be 1 or 100%. So sometimes things that we typically would round up, we might have to round down just to keep things at that 100%. And that's part of estimating. It's not always an accurate tool. 380 over 1470 gives us 0.26 or 26%. 100 over 1470 gives us 0.07 or 7%. This is the one that I rounded down. It was 170 over 1470 is actually about 0.115, which typically we would round up to 0.12. But because these three all got rounded up, I rounded this one down as it was the lowest and just made it 0.11, which made it 11%. And then we can just add our decimals. They should give us 1. We should add our percents. They should give us 100%. So this is just one way to find our probabilities. Now what I want to show you is how you can sometimes write probabilities in a more simplified version. So here what we have is how probabilities are typically written in a mathematical form. We have probability, and then the desired outcome is in parentheses, and then we just put the outcome number over the total. So I have three situations here. We have probability, which we usually abbreviate as just P, and then inside the parentheses we put the outcome that was desired. We wanted black males. Well, based off of that, we had 820 from our data set before, and we had 1470 as a total. So all we do is we take our calculator. I'm going to use my phone. And we take 820 and divide by 1470. And we get a big long decimal that is about 0.56. Now typically we'll usually stick with our decimal. Sometimes we'll use the fraction. And then some of you may prefer to turn these into decimals at times, remember, or change these into percents. So if you remember to do that, all we have to do is times by 100 to get 56%. So 56% of all these squirrels were black males. Second situation here is a little bit different from the table. From the table, we had the females split into two parts. What I've done is said, I want all females. So what we have to do is we have to put those two parts back together. The 100 comes from our black females, and the 170 comes from our gray females. So we have to add them together to get the total number of females, which would be 270, and we still have the same total. So we then take our 270, divide by 1470, and we get a decimal of about 0.18. So 0.18 would typically be our probability. We can turn that into a percent for those of you more fond of that, and we would get about 18%. So we get 18% of the squirrel population as being females. Then we have another one. This one is saying probability of a red squirrel. Well, if you remember from the data, there were 0 red squirrels. So this is 0 over 1470, which is going to give us 0, which if we times by 100 is 0%. The idea here is that we can ask for something that didn't happen. And because of that, we can get a 0. We can also ask for something that would give us it happening all the time, or the total, which would give us a 1, and that's what the total was from the other one. So if there are any questions on probability, or you didn't understand something, make sure you pause, rewind, and watch again, and bring those questions to class. Thank you.